So logical thinking. So it's made up of 6 questions. Given that August 18th, 2023 is Friday, which day of the week will it be? August 15th, 2031. So the first thing that we want to do is let's try to find the day of August 15th, 2023. So since August 15th is 3 days before 18, so just work backwards. So 17 will be Thursday, 16 will be Wednesday, and 15 would be Tuesday. Okay. Next, as we know, for every leap year, 5 years is added. Okay. For every 4 years, there is 1 leap year, so that would be a total of 5 days added. Okay. So the first thing that we want to do here is first, so subtract 2031 by 2023. So this becomes 2. 11 minus 3, that's equal to 8. So that's going to be 8 years. Okay. So that's equal to 2 leap year cycles. So that means there will be a total of 10 days added. Okay. So 8 is congruent to 5 days added. Okay. So we have 5 times 2. So we have 10 days added. So next, we just need to divide 10 by 7. So 10 divided by 7 is equal to 1 remainder 3. So that means at 3 days, a total of 3 days will be added. So 10 days added is just congruent to 3 days added. So since August 15, 2023 is Tuesday, so we just count 3 days from Tuesday. So that's going to be Wednesday, Thursday, and then finally Friday. So the final answer here should be Friday. Okay. Any questions for number 1? If there are no more questions for number 1, let's go to the next one. Grandma is distributing 900 ml of lemon juice among her 4 grandchildren, Ben, Evans, John, and Tim. Given the ratio of the volume of juice received by Tim and that by Ben is 1:2, the ratio of the volume of juice received by Ben to that by John is 3:2, and the ratio of volume of juice received to John to that by Evans is 4:5. How many ml of juice does received by Ben and John? Okay. So let's focus first on our first given, Tim to Ben. That's T is to B. That's equal to 1:2. Next ratio is Ben to John. So that's B is to J. So that's equal also to 3:2. And then by John to Evans. So that's equal to 4:5. Okay. So let's focus first on this first part. So let's try to combine this. So in order to do that, the least common multiple of 2 and 3 is 6. So we want B to be 6. Okay. So B is 6 here. So that means this one is multiplied by 3. So 1 times 3 would be 3. Here, so since this is 3 and this becomes 6, so that means it was multiplied by 2. So we need 2 times 2. So that's 4. So this is our ratio for T is to B is to J. Now we need to incorporate that with J is to E, but J is already 4, so that's good. So we can just add our E right away, which is to 5. Now we have the ratio of the 4 grandchildren. We just need to add the ratio. So we have 3 plus 6 plus 4 plus 5, that's equal to 15. After that, we need to divide 900 by 15 so that we can multiply the correct constant, okay? So 900 divided by 15, 90 divided by 15, that's going to be equal to 6. Yep. 6 times 15 is 90, so we have a total of 60, okay? That means we need to multiply our ratio by 60, but since we're only looking by Ben and John, so we just need to multiply Ben and John by 60, okay? So Ben and John is 6 plus 4, so that's equal to 10. And then multiply that by 60, 10 times 60, which is equal to 600. So the final answer here should be 600. Wait, why is it 500? What's 90? 900 divided by 15. Ah, wait, it should be 18. Wait. Our sum was 18, not 15. Okay, we need to do that again. 6 plus 4 plus 5 plus 3 is 18. Okay, my bad. Sorry for that one. So we need 900 divided by 18. So that's going to be equal to 50. So we need 6 plus 4, which is equal to 10. And then 10 times 50 is equal to 500. So the final answer here should be 500. Okay. Any questions for number 2? Sorry for the error.
No.
Okay, let's go to the next problem. There are several lions and kangaroos in a zoo. If the number of kangaroo is 6 more than 6 times the number of lions, and the total number of legs of a kangaroo is 196 more than of a lion's. How many kangaroos are in the zoo? So first, given the number of kangaroo is 6 more than 6 times the number of lions. So let's turn it into an equation. So T is our number of kangaroo and our number of lions will be L. Okay. So T is equal to 6 plus 6L. So 6 more than 6 times the number of lion. Next, the total number of legs of kangaroos is 196. So as we know that a kangaroo has 4 legs, so that's going to translate to 4K in equation. So it's said to be 196 more than of the lions. So a lion has also 4 legs, so we can make that 4L. Okay. So next, we need to solve for the number of kangaroos. So the first thing that we want to do here is get rid of our L. Okay. We need to get rid our L because we want to solve for K. So to do that, from the first equation, we can multiply this by 2. So this becomes 2K is equal to 12 plus 12O. Meanwhile, the second equation, we can multiply this with 3. So this will become 4 times 3. So that's 12K. 196 times 3, 8. That's equal to 588. And then 4 times 3, that's equal to 12. Now we subtract our two equations. So 12K minus 2K. So that's going to be equal to 10K. Next, we need 588 minus 12. So that's equal to 576. And then 12L minus 12L is 0. Wait. More than of the lion. 196 times 188. Wait. That's weird. Wait, let me double check the questionnaire. Do we have the correct given? Wait. We multiply this by 2. That's 2k. 6 times 2, 12. Next, we have multiplied by 3. Oh, wait, this is kangaroo. Yeah, okay. I'm thinking of giraffe. Okay, I don't know why. It's okay. A kangaroo has 2 legs. Okay, let's change our equation. So 2L is equal to 196 plus 4L. Okay. So multiply this by 3. So this will become 6K, 2K. So multiply this by 3, that's 6K is equal to 196 times 3. So that's equal to 588 plus 12L. Now we subtract the two equations. 6 minus 2, that's equal to 4K. 588 minus 12, that's equal to 576. Okay, now we just need to divide by 4. 576 divided by 4, so that's equal to 1. 1 times 4, that's 4. 17, 4 times 4 is 16. So we have a total of 444 kangaroos. Okay, let's double check if we got it right. Yep, that's correct. Okay. So kangaroo has only 2 legs, my bad. I'm sorry. I was thinking of 4. Okay, any questions for this one? If there are no more questions, then let's go to the next one. Find the average of the following number sequence. So I think this one's quite easy. So as what we can observe, this is an arithmetic series because this one here is when you add 8, and then this one here is you add 8, and add 8. So when you have an arithmetic series, all you need to do is add the first number and the last number. So we have 2,203 plus 555. So that's equal to 2,758. And after that, you divide the sum. 7 divided by 2 is 3. 3 times 2 is 6. So we have 15. 7 times 2 is 14. We have 18. So that's 9. The final answer here should be 1,379. Again, you just add the first and the last number and you divide it by 2. That should be your final value. Okay. Any questions for this one?
Yes. I have
Yes.
a question.
Okay, what's your question?
I don't understand uh why you divide 2,758 to 2.
When you're getting the average of an arithmetic series, the general formula is first plus last over 2. That's your general formula for arithmetic series or average of arithmetic series.
Oh, thank you. I understand now.
If there are no more questions, then let's have the next one. How many integral solutions are there? How many integral solution are there for x is greater than for x minus 3 over 5 but less than 2? Ah, wait, the other way around. Yeah, no. So the first thing that we want to do here is we get rid of our denominator 5. So to do that, we multiply 5. So 8 times 5, that's 40. Here, we just cancel the denominator, so that becomes 4x minus 3. And then 2 times 5, that's equal to 10. Next, we get rid of negative 3. So to do that, we add 3 to each side. So 40 plus 3, that's 43. 4x minus 3 plus 3, that's just 4x. And then 10 plus 3, that's 13. So after that, we just need to divide by 4. So 43 divided by 4, that's equal to 10 and 3/4. And then 13 divided by 4, that's equal to 3 and 1/4. Okay. So since we're looking for integer solutions, so first let's get our first number where x is less than 10 and 3/4. So that should be 10. Okay, so that's the first number in our solution here. And then what's the last number that is bigger than 3 and 1/4? So that should be 4. Okay, so our solutions is from 10 to 4. So we just need to count how many integers from 10 to 4. So the basic formula for that is just biggest number minus smallest number plus 1. So that's equal to 10 minus 4 is 6, 6 plus 1, 7. So that means we have 7 integral solutions. Okay, any questions for number 5? Yes?
No.
What's your question? Why is it 4? How about for negative integral solutions? I don't think that we have a negative integer solutions. Do we have a negative integer solutions? I don't think that we can get a negative solution. And not 3. Why not 3? Because if 3 here, okay, let's say 3. Okay, let's make that 3. Is this true or not? Okay, wait, not my bad. So you said someone asked if x is 3. Okay, let's check it. Is this true or not? This is not true. 3 is not bigger than 3 and 1/4. That's why 4 is our first integer solution. Why is it added by 3 there? This one here. So we add 3 here so that we can get rid of this 1. Okay, because we want to solve for x. So to do that, we need to add 3 so that this will be removed from your middle term. Okay, any other question? Okay, there are no more questions, so I think that's already fine. So now let's move on to the next question. According to the pattern shown below, what should be the number filled in the blank? Okay, where's the pattern? Wait, let me just check the question because the pattern is not showing. So the pattern is 1, 1, 2, 3, 5. 1, 1, 2, 3, 5. 9, 16, 29. 9, 16, and then 29 blank. Okay. So that's the. So on first hand, it looks a little bit complicated. But the first thing that I can observe is this is a little bit similar to Fibonacci. But it's not really Fibonacci. Because if we try to observe 1 plus 1 is 2, 1 plus 2 is 3, 2 plus 3 is 5, but 5 plus 3 is not 8. Okay. So it's not a Fibonacci. So let's try another one. So the one that I can observe is if I add these 3 numbers and subtract 1, I can get 3. Okay. 1 plus 1 plus 2 is equal to 3 minus 1. Okay. So let's do that to the next one. 1 plus 2 plus 3, that's equal to 5 minus 1. Is it? Plus rather, plus. So 5 plus 1, which is 6. Okay, that's correct. So to the next one, 2 plus 3 plus 5, is it equal to 9 plus 1? Yep, that's also valid. So the next one, 3 plus 5 plus 9, is it equal to 16 plus 1? Yep, that's also correct. So we have already proven that this is the correct pattern. So we just need to do this one. So 9 plus 16 plus 29. So that should be equal to, so 9 plus 16, that's equal to 25. 25 plus 29, that's equal to 54. So that means we need here 53 plus 1. So the answer here should be 53. Okay, let's check. Yep. Okay, any questions for number 6? Again, the pattern here is you add the previous 3 numbers, and after that, you add 1. You subtract 1, rather. Okay, any questions for number 6? If there are no more questions, then we're done with the first part. So the next one is algebra. So algebra is also 6 questions. So that's going to be number 7 to 12. So given that A and B are distinct roots of 4x squared plus 24x plus 18 is equal to 0, find the value of A squared plus B squared. So we can use here Vitas formula. So based on Vitas formula, so the sum of the roots, which is A plus B, is just equal to negative B over A. So our negative B, or the numerical coefficient of x, so that's going to be negative 24. And then your A is 4. So that should be equal to negative 24 divided by 4, which is negative 6. Okay. Next, another one is your product of your roots. So that's going to be A times B, or AB. So that's equal to C over A. So your C is 18 and your A is 4. So we have 18 divided by 4. So that's equal to, that's going to be 9 over 2. Yep, 9 over 2. Next, we need to get A squared plus B squared. So the first thing that we can do is we know that A plus B quantity squared is equal to A squared plus 2AB plus B squared. So we already have the value of A plus B, which is negative 6. So we can plug that in. So we have negative 6 squared. Next, we also have a value of AB, which is 9 over 2. So we have 9 times 9 over 2 plus B squared. So this one is equal to 36. Because negative 6 times negative 6 is 36. Next, 2 times 9 halves, that's equal to 9. So now we have this equation. Now we just need to solve for A squared plus B squared. So to do that, we just transfer 9 here. So that's equal to 36 minus 9, which is equal to 27. So the final answer here should be 27. Okay, any questions for number 7?
Teacher, what is Vieta's formula?
Vitas formula is a shortcut that we can use to get the sum and the product of the roots. Okay, the sum of the root is given as negative B over A, where B is the numerical coefficient here. Wait, let's make the AX squared plus BX plus C. So based on Vitas formula, then the sum of the roots is just negative B over A. Okay, so that's negative 24 over 4. And then the product is C over A, so we have 18 over 4. Okay, any other questions? I think there are no more questions, so let's move on to the next problem. Number 8. Given that the real numbers x and y satisfying 3x minus 2y is equal to 10 and 4x minus 5y is equal to 4, find the value of 4xy. So this is system of equation. So the first thing that we can do here is we can do elimination. So that's my preferred way of solving. So first thing that I want to do is I multiply 2 here. So that will become 6x. No, not multiply by 2. Multiply by 5 rather. I want to multiply this by 5. So 3 times 5, that's 15x. 2 times 5, that's going to be negative 10y. And then 10 times 5 is equal to 50. Okay. Meanwhile, the second equation, I want to multiply this by 2. So we have 8x minus 5 times 2, that's also 10y. Then 4 times 2 is 8. Now I can eliminate 10y. So to do that, all I need to do is subtract the 2. Okay. 15x minus 8x, that's equal to 7x. Negative 10y minus negative 10y, that's 0. And then 15 minus 8, that's equal to 42. Now I just need to divide by 7. So x would be equal to 6, okay? So after that, we have the value of x now. So we just need to solve for the value of y. So to do that, you can use any of the two initial equations. So let's use this one. So we have 4 times 6 minus 5y is equal to 4. So 4 times 6 is 24. That means negative 5y is equal to 4 minus 24, which is essentially equal to negative 20. So divide negative 5 both sides. We have y is equal to 4. Now we have the value of x and y, so we just need to solve for 4xy. So we just plug in our values that we solve. So we have 4 times 6 times 4. So 4 times 4, 6 times 4 is 24, and 24 times 4, that's going to be equal to 96. So final value here should be 96. Yep. Okay, any questions for this one? What is the answer for number 7? I forgot, sir. I'll show it again later. Any questions for 8 first? There are no more questions. Then let's go back to number 7 because someone's asking for the answer. Wait, why 4, 6? What do you mean 4, 6? This one here. We use the second equation. You can use any of the two equations. That was the initial given. You just plug in the value of x, which is 6. Okay, any other questions? Okay, I think there are no more questions. So let's go back to 7 first because someone's asking for the answer. For 7, the answer is 27. Okay, let's go back to number 9. Let's go to number 9. Find the minimum value of 16x squared plus 24x plus 23. So for this one, all we need to do is express it in its vertex form. So first, okay, so to express this in vertex form, first we need to isolate your first two terms. So that's 16x squared plus 24x, okay, plus 23. After that, you want to factor out your number here. So you factor out 16. So 24 over 16 x. Okay. So let's try to simplify this first. So 24 over 16, you have a common factor of 8. So 24 divided by 8 is 3. 16 divided by 8, that's 2. Okay, so that's 3 halves. So let's change this to 3 halves. Okay. Next, we want to do completing the square. So we want to make this a perfect square trinomial. So to do that, all we need to do is first get 3 halves divided by 1 half. Wait, divided by 2 rather. So that's just equal to 3/4. Okay. After dividing it by 2, you just need to square this. So that's going to be equal to 9 over 16. Okay. So we need to add 9 over 16 here. So make this a perfect square trinomial. But as what we can observe, since we added 9 over 16 here, we need to subtract that back here. So since there's a 16 here, so that's going to be 16 times 9 over 16. So that's equal to 9. So since we added a total of 9 here, we need to subtract that back here so that it's still balanced. Okay. Next, we need to express this one in its factored form. So that's going to be 16 times x plus 3/4 squared. Okay. Next, 23 minus 9, that's going to be equal to 14. After that, the number here, okay, or your k, that's your a times x minus h squared plus k. So this is the form. So your k is going to be your minimum or your maximum value. So for this one, your minimum is 14. Okay, any questions for number 9? If there are no more questions, then let's do the next problem.
Hello.
Yes.
Why do you divide 24 by 16?
Why did you divide 24 by 16? Because we factored out 16. We factored out 16. It becomes here. That's why it's 24 over 16. So it was 24 over 16, and then we just rounded up to 3 over 2. We just simplified 24 over 16. That's why we have 3x. So what is the x? What do you mean x? That's your vertex form. Any other question? Again, what we did here is we factored out 16. That's why it was 24 over 16, which is simplified as 3/2. Where did negative 9 came from? So as what we can observe here, we added 9 over 16 for the completing the square. So 6 times 9 over 16, that's 9. That's why we need to subtract 9 here. Okay, any other questions? If I'm correct, we can use the vertex form from here, right? Yep, this is the vertex form. So if there's also another way where you have the solution where the formula for h and k. So if you have that one, you can use that one. Okay, I think this is already fine. So that's it. So let's have the next one. Okay, for this one, factorize x squared minus y squared plus 14x plus 49. So what we need to do here is difference of two squares. So first, I'll isolate this part. So we have x squared plus 14x plus 49 minus y squared. Okay. So what we can observe, this is a perfect square trinomial. So we can write this in the form of x plus 7 quantity squared minus y squared. So what we have here is difference of 2 cubed by 2 squares. So it's like a squared minus b squared, which is equal to a plus b times a minus b. So we can use that here. So here we will get x plus 7 minus y. And then here we have x plus 7 plus y. So this is our final factored form. Okay, so this one's pretty easy actually. It looks complicated at first, but you just need to rearrange and then you can apply difference of these squares. Okay. Any questions for number 10? Any questions for number 10?
Sir,
Yep.
is it okay to have x x plus y plus 7
Yep. You made
minus
rearrange this one. Yep. Yeah. Okay, that's still accepted. Don't worry about that one. It will be checked manually. Okay. Any other question? Any other questions before we proceed? I think there are no more questions, so let's have number 11. Find the sum of the possible values of x plus 10 minus 4 minus x is equal to 6. Okay, let's try to do the long way first. So the long way here is first, we find what will make this 0. So we know that the number that will make this 0 is negative 10. So we put that in our number line, negative 10. Here, the one that will make this 0 is 4, because 4 minus 4 is 0. So that is our boundary. So let's try to do number line test. So here, if you do negative 10, so our number less than negative 10, let's say negative 11. Okay. Negative 11 plus 10 is negative, okay? So that means your absolute value function will multiply by negative 1. That's negative 1 of x plus 10. Here, if we try to substitute negative 11, that's 4 plus 11, so that's positive. So that means it won't change, okay? So that's still minus 4 minus x is equal to 6. So negative x minus negative x. So that's going to be negative x plus x. So that's equal to 0. Next, we have 10 minus 4, so that's 6. So that's 6 equal to 6. So that's correct. So that means all of the numbers here are solutions, okay? How about here? So let's try to pick a number, let's say 0, because 0 is between this. So 0 plus 10, that's going to be equal to positive. So that means your absolute function won't change. So that's still x plus 10. Here, 4 minus 0, that's also positive. So your absolute value function won't change. So x minus negative x, that's going to be 2x. 10 minus 4, that's going to be 6. So 6 minus 6 is 0. So x is 0. Okay, so your solution here is just 0. Okay. Next, let's go here. So as what we can observe, we can use 5. So 5 plus 10, that's 15. So your absolute function won't change in value. So that's still x plus 10. If we try to substitute 5 here, so this is negative. So that means you need to multiply negative 1 to your absolute value function. So that will become plus 4 minus x is equal to 6. So x minus x, that's going to be equal to 0. Right? 0. Okay. 10 plus 4 is 14. And then 14 would be equal to 6. So this is invalid. Wait. No solution. Wait. Let me double check here. I think we made a mistake here. Negative x minus negative x is 0. 10 minus 4. What's the answer? Negative 11. Okay, that's negative. Negative 11. Positive. Okay. Let me check now. Wait, I made a mistake. We have here negative times 10, so that should be negative 10 minus 4. So that should be negative 14 is equal to 6. So there's no solution. So your only possible solution is x is equal to 0. Yep. Negative 10 minus 14 is negative 14. So that's it. So the only possible solution is 0. Okay. Thank you for that one. Okay, any questions for number 11? If there are no more questions for 11, let's have number 12. How many integer solutions? Okay, this is similar to the previous problem that we had. So again, all we need to do is first get rid of our denominator. So we multiply 4 here. 9 times 4, that's going to be equal to negative 36. So we cancel 4 here. So we have 2x minus 5. Here we have 8 times 4, which is positive 30. Next, we get rid of negative 5. So to do that, we add 5. So negative 36 plus 5, that's negative 31. Here we just cancel positive 5 and negative 5. So we have 2x. 32 plus 5 is 37. Next, we divide by 3. So negative 31 divided by 3. So that's going to be equal to negative 10 and 1/3. Yep. So we have here x. So 37 divided by 3, that's going to be equal to 36 is divisible. So that's going to be 12. 12 and 1/3. Yep. So x is greater than this number. So what's the first number that is greater than negative 10 and 1/3? So that's going to be negative 10. So that's your first solution. Next, what is the last number that is less than 12 and 1/3? So that's going to be 12. Okay. So now we need to find how many numbers from 12 to negative 10. So again, we use the same formula. So bigger number minus smaller number plus 1. 12 minus 10 or minus negative 10, that's going to be 12 plus 10. So that's 22. And 22 plus 1 is going to be equal to 22. So the final answer here should be 22. Okay. Any questions for number 12? Any questions for this one? If there are no more questions, then let's go to the next problem. Number 2. Find the value of the expression square root of 24 plus 10 square root of 24 plus 10 square root of 24 plus dot dot dot. So the first thing we want to do is we let this be x. Okay. That should be like this. That extends, okay? Break that, that. So in order for us to have a pattern, we multiply this by 10. So we have 10x is equal to this one. Okay. So what you can observe, this is just similar to 10x. Okay. So you can substitute that as 10x is equal to 10 times 24 plus 10x. Okay. And then divide 10 both sides. So that's just equal to x is equal to 24 plus 10x. Okay. But if you're already familiar with this problem, you can just automatically change this one to x. Okay. So here, we just need to solve for x. So to do that, we want to have a quadratic equation. So first, we square both sides. So x squared is x squared. And then if we square this one, we're going to get rid of the radical signs. So that will become 24 plus 10x. So simplify this one. So we have x squared minus 10x plus 24 is equal to 0. Then we just need to solve this like a quadratic equation. Okay. So your possible roots for 24, we got 8 and 3. But 8 and 3 does not have a difference of 10. So let's have another one. We can have 12 and 2. Okay. 12 and 2 has a difference of 10. So we can use that. So we have x minus 12 times x plus 2 is equal to 0. So that means our values for x is equal to 12, and we also have x is equal to -2. But as what we can observe here, we have a radical sign, so we cannot have a square root of a negative number because that's imaginary. So we just consider the positive root. So the final answer should be 12. Okay. -24 is minus. Okay, wait. Let me double check. If 24 was minus, yeah, 24 is minus. Yep, but still the same. Sir, why is -2 not counted as the answer? Because if you put -2 inside the radical, then that would be a real number. Again, you cannot have a square root of a negative number. Okay, any other question? We only want the positive root because a negative cannot have a square root, because that would be imaginary. Okay, if there are no more questions, let's have number 40. Find the remainder of 41 raised to 40 when divided by 7. Okay, so we want to get 41 raised to 40 mod 7. Again, the first thing that we can do is first get 41 divided by 7. So that's going to be equal to 6 times 7. So 6 times 7, that's around 42. No, 5 lang. 5 times 7 is 35. So we have a remainder of 6. Okay. So that means, wait, let's try to write this one first. So that could be written as 41 mod 7. Okay. So since it has a remainder of 6, then you can write this one as congruent to 6 mod 7. Okay. Next, you can manipulate this one by adding 7 or subtracting 7. So the first thing, the better way we can do is we subtract 7. Okay. Your goal is to get values like 1, 0, or -1. So 6 minus 7 is -1. So that will be written as -1 mod 7. So we know that 41 mod 7 is congruent to -1 mod 7. Okay. So we can use this information to substitute here. So 41 raised to 40 mod 7 could be also written as -1 raised to 40 mod 7. So as we know, -1 raised to an even exponent would become +1. So this is written as 1 mod 7. Therefore, you have a remainder of 1. Okay. Any questions for number 14? Where did -1 come from? Again, first, we solve for the remainder of 41 when it's divided by 7. So the remainder is 6. We have 6.7. Again, we can change the value here by adding multiples of 7 or subtracting multiples of 7. What we did here is we subtracted 7. So 6 minus 7, that's -1. That's why we have -1 mod 7. Okay, any other questions? If there are no more questions, then let's have the next problem. If x plus 5 is a factor of the polynomial 45x squared plus 102x minus c, find the value of real number c. So if a polynomial is a factor, then that means when x plus 5 is equal to 0, then x is -5. So this means if you substitute -5 to your polynomial, it should have a value of 0. So we just substitute that. It should be equal to 0. 45 times -5 squared, that's equal to 45 times 25. Okay, wait, let's solve for that one first. That's equal to 1,125. Next, we need 102 times 5. That's equal to -510. So we transfer C here. So this will become equal to C. So we need 1125 minus 510. So that's equal to 715. That means the final value of C would be 715. Oh, wait, 615 rather. That's it. Any questions for this one? So this one actually easy as long as you know the technique.
Sir, how do we know that x plus 5 is equal to 0?
Because we know that it's a root or it's a factor. So it's automatically equal to 0. Again, if it's a factor, then x plus 5 is equal to 0. Okay, any other question? I guess there are no more questions. So let's proceed. So that's the last number before our 10-minute break. So the time right now is 2:02. So let's all be back by 2:12. Okay, you can take your break now. Hello, I'm back. Can you hear me? Hello, can you hear me, guys? Can you get I get a thumbs up if you can hear me? Okay, let's go to the next one, number 16. Find the sum of all positive factors of 680. So first, we need to prime factorize. So 680, that's 68 times 10. So 68, that's going to be equal to 2, 34. This one is 2 times 5. And then 34, that's going to be equal to 17 times 2. Okay. So our final prime factorization should be 2 cubed times 5 times 17. So next, using the formula for sum of positive factors. So you start with 2 cubed. So just get its sum for descending powers, starting from 2 raised to 3. So you have 2 raised to 3, 2 raised to 2, 2 raised to 1, and 2 raised to 0. So that's going to be equal to 2 raised to 3, that's 8. 2 raised to 2 is 4, 8 plus 4 is 12. 12 plus 2 is 14, and then 14 plus 1, that's going to be 15. We do the same process for Farsh. So we have 5 raised to 1 plus 5 raised to 0. So that's 5 plus 1, so that's going to be 6. And then the same process for 17. That's 17 plus 1, so that's going to be equal to 18. Now we just need to multiply the three numbers. So let's have 15 times 6 times 18. So 15 times 6 times 18, that's equal to 1,620. That should be our final answer. Yep, I am presenting. Can you see my screen? Any questions for number 16? Does anyone have a question for number 16? Okay, if there are no more questions, then sub number 17. So given that the real number x greater than 0 satisfies x plus 1/3 is equal to 13, find the value of x squared plus 1 over x. So first, let's try to square this one. So if we square this, so this is equal to x squared plus 2 plus 1 over x squared. So 13 times 13 is 169. Okay. So since we're only looking for x squared plus 1 over x squared, so we just transfer that here. So x squared plus 1 over x squared, that's going to be equal to 169 minus 2, or that's equal to 167. So that should be our final value. Okay. Any questions for number 7? So this one is pretty easy actually, as long as you know that.
Sir, where did you get the 2 from?
Wait. So remember when you're squaring a binomial. So first, get the square of this, so that's x squared. Next, get the square of this, so that's 1 over x squared. And for the middle term, this one times this one times 2. So x times 1 over x, as we can observe, is just equal to 1, and 1 times 2 is 2.
Oh, okay.
Any other questions? No more questions. So let's have number 18. Okay, find the positive integer k raised to 5 is satisfying k raised to 5 is equal to 141,985,7. So the first thing that we have to do here is we know that this is 7, so that means we're looking for an odd number. Okay, since your unit digit is an odd number, then we're looking for an odd number too. Okay, so first 10 raised to 5, so that's going to be equal to just 5 zeros and then 1, so that's around 100,000. So okay, next we have 20 raised to 5, so that's going to be 2 times 10, 2 raised to 5 times 10 raised to 5, so that's going to be equal to 5 zeros. And then 2 times raised to 5, that's 2 times 2, 4, 4 times 2, 8, 8 times 2, 16, 16 times 2 is 32. So that's this. That's what we can observe. This one is in the middle of 20 to 10. Okay. So we just need to find odd numbers from 20 to 10. So we have 11, we have 13, we have 15, we have 17, we have 19. So first, for 11, so the unit digit pattern for 11, so that's always equal to 1, okay? The unit digit pattern for 11 or 1 is 1, so that means this one is already error. So for 3, your unit digit pattern for 3, or you just need to get 3 raised to 5. So 3 raised to 5, that's going to be equal to 3 times 3 is 9, 9 times 3 is 27. 27 times 3, that's equal to 27 times 3, 81 times, wait, 3 times 3 is 9, times 3, 27, times 3, 81, times 3, that's 243. So as you can see, unit digit is 3, so that's also error. Wait, let me double check. Yep. So let's go to the next one for 15. So that's just 5 raised to 5. So 5 raised to 5, the unit digit is equal to 5. So that means this is also error. Next, we have 7 raised to 5. So the unit digit is 7. Because the unit digit pattern for 7 is 7. Then 7 times 7 is 9. 9 times 7 is 3. 3 times 7, that's going to be 1. Okay. So since it's 5, so it's gonna go back to 7. So since unit digit pattern, unit digit here is 7, so that means K should be 70. Okay, any questions for this one? Yep. We use odd numbers because we know that the last digit here is 7. So it's impossible to have an even number multiplied by itself that has an odd value. Okay. It's impossible to multiply an even by itself that will result to an odd number. Yep. If the last number was even, then we list out even. Correct. Any other questions? There are no more questions. Let's have number 19. Given the interior angles of an irregular dodecagon are this one as listed, what is the sum of the interior angle? So all we need to do first is get the total angle of a dodecagon. So we use the formula n minus 2 times 180. So we know that a dodecagon has 10 sides. So that's going to be 10 minus 2. So that's 8 times 180. So 8 times 180, that's equal to 1,440. Next, we just get the sum of all of these angles. So that's 175 plus 105 plus 124 plus 246 plus 96 plus 128 plus 193 plus 122 plus 117. That's equal to 1,306. So we just need to subtract the 2. To borrow this, 10 minus 6, that's going to be equal to 4. Borrow again. So this, wait, 3 minus 0, that's, wait, do we have the correct sum? Wait, let me double check. Yep. Oh, wait, this is a dodecagon. Wait, my bad. Dodecagon has 12 sides. Should be 10. Should be 10 times 180 again. This is a dodecagon. I was thinking of decagon. So that should be 1,800. So first borrow. So 7, 9, 10. 10 minus 6 is 4. 9 minus 0 is 9. 7 minus 3 is 490. That's the total of the remaining angles. Can you go back to the last slide with the solution? Wait, after number 19. Okay, any questions for number 19? So, I made a mistake. I was thinking that dodecagon has 10 sides, but dodecagon has 12 sides. Dodecagon is 12 sides, not 10. I was thinking of decagon when I was solving it. Okay, any other questions? If there are no more questions, then someone's requesting for number 18. Let me show that again. So this was the formula for 18. Dodecagon is 12 sides. That's the general formula, guys. For getting the sum of an interior angle, the general formula is n minus 2 times 180, where n is the number of sides. Dodecagon is 12 sides. Okay, if there are no more questions, then let's have the next one. Number 12. If a straight line passes through point A, 618, in a rectangular coordinate system, and the slope of L is 6, find the sum of the x-intercept and y-intercept. Okay. So for slope, okay. Let's try to write the equation first. So the general equation is like this: y minus y sub 1 is equal to slope. So slope is m times x minus x sub 1. So just substitute. So your y sub 1 here is 18. Your slope is 6. And then x sub 1 is also 6. So just simplify this. So 1 minus 18 is equal to 6x minus 36. So y is equal to 6x. So transfer that here. So this becomes negative 18. Now we solve for x-intercept. So we start with x-intercept first. So if you're solving for x-intercept, just turn y to 0. So 0 is equal to 6x minus 18. So 6x is equal to 18, which means x is 3. Now we go for y-intercept. So we turn x to 0. So y is equal to negative 18. So 6 times 0 is 0. So this just becomes 0. So now we have the x and the y-intercept, and we're finding for the sum. So negative 18 plus 3 is just equal to negative 50. So that should be the final answer. Okay. Any questions for number 12? Formula of equation. This is the point and slope equation. Point slope form of a line.
Mister, how you find m is 6?
It's given. Slope of L is 6. That's your slope.
Also, m is L.
Slope. The slope. Okay. Any other questions? If there are no more questions, then let's have the next one. Given the side lengths of a triangle are 7, 24, 25, find the area of the triangle. So as we know, this is a Pythagorean triple, but let's try to check it to be 100% sure. So 7 squared plus 24 squared, so that's equal to 49 plus 24 times 24, that's equal to 576. So add the two. 49 plus 576, that's equal to 625. Now let's solve for 25 squared. So 25 squared is 25 times 25, so that's 625. So since they are equal, then it's proven that they are a Pythagorean triple. So we just need to solve this like this. So using area is equal to base times height over 2. So 7 times 24 over 2. So that's just equal to 7 times 12. So that's equal to 84. So your area here should be 84. Okay. Any questions for number 21? Don't worry, guys. Recording will be emailed to you. So just try to review it again. Okay. A copy of the recorded lecture will be sent, and also a copy of the material. Just check your emails. Okay, let's have the next one. There are 10 points on a circle. How many different octagons can be drawn with those points as vertices? So this is actually quite easy. So octagon has equal to 8 vertices. So all we need is then choose 8. If you choose 8 points from the 10 points present on the circle, that's equal to 10 factorial over 2 factorial times 8 factorial, which is 10 times 9 times 8 factorial over 2 times 1 times 8 factorial. Let's cancel this and then cancel this. So 5 times 9 is 45. So the final answer here should be 45. Okay. Any questions for number?
What is 10C8?
Combination. Then choose 8 is n factorial. The formula here is n choose r is equal to n factorial over r factorial times n minus r factorial. So you just plug that in and then solve for it.
Okay.
Any other questions for 22? Okay, if there are no more questions, then let's have number 23. Given the sidelines of a triangle are 21, 28, and 30.
Mister,
Yes.
can I know number 22 answer?
What was that?
Okay, done.
Okay, for this one, so this is actually also another Pythagorean triple, but we can also, another way to check this is to try to simplify this. So this is all divisible by 7. So 21 divided by 7 is 3. 28 divided by 7 is 4. And 35 divided by 5 is 5. So 3, 4, 5 is the most famous Pythagorean triple. So therefore, this is a Pythagorean. This is a right triangle. So just solve it like area is equal to base times height over 2. So that's 21 times 28 over 2. Or that's just simply equal to 21 times 14. So let's try to get the value. That's equal to 294. So that should be our final value. Okay. Any questions for number 22?
Sir, if the triangle is not right angled, is there a formula to find the area?
Yep, we need to use Heron's formula. So Heron's formula is like this. First, you get the semi-perimeter. So that's the perimeter divided by 2. Okay. I think you already know how to get perimeter, right? Next, we let these our sides be ABC. Then it's going to be square root of S times S minus A times S minus B times S minus C. So in this case, let's solve for the semi-perimeter. So 3 plus 4 plus 5, 21 plus 28 plus 35. That's 21 plus 28 plus 35. That's 84. Divided by 2, that's equal to 42. Okay. So your S is 42. S minus A. So 42 minus 21. That's equal to 21. S minus B. 42 minus 28. That's 14. And then S minus C. That's 42 minus 35. That's 7. Get the square root. So wait, this is 7. 14 is 7 times 2. 21 is 7 times 3. 42 is 7 times 6. Okay. So as we can observe, we can extract 2 sevens. We can also extract the 6. So we add 7 times 7 times 6. So 7 times 7 times 6, that's also 294. That's Heron's formula. Any other questions? If there are no more questions, let's go proceed to the next one now. A solid cuboid is formed by merging 2024 cubes with side length 1. What is the smallest possible volume of total surface area of the cuboid? So to get the smallest possible total surface area, that means we need to make sure that the dimensions are as compact as possible. So first, let's try to get the from factorization of 2024. So that's 1012 times 2. Then 1012, that's going to be equal to 506 times 2. 506 times 2, that's going to be equal to 253. And 253, that should be divisible by 23. So that's 23 times 11. So therefore, our prime factorization is 2 cubed times 23 times 11. So our only possible integer dimension is 8 times 23 times 11. So now we get the surface area. So surface area, so that's going to be equal to 2 times 8 times 23 plus 2 times 23 times 11 plus 2 times 8 times 11. So let's start first with 8 times 23 times 2. Please do not annotate. That's equal to 368 plus 2 times 23 times 11. So that's 506. 2 times 8 times 11. So that's 176. And then add the 3. 368 plus 506 plus 176. That's 1050. So the final answer here should be 1050. Wait. What? He's looking for the smallest, not the largest. 8098 is the largest. So this is the wrong. This is an error on the solvent. So this is wrong. Okay, 8098 is talking about the largest. Okay. Let's change this to largest. If we're looking for the largest, okay, let's try to solve for that one also. Okay, for smallest, this is the answer, but let's try the largest. When we're looking for the largest, then your dimension is just as far from each other. So that's just 2024 times 1 times 1. So getting the surface area, so that's 2024 times 1 times 2 plus 2 times 2024 times 1, and then finally 2 times 1 times 1. So this is equal to 2 times 2024, that's 4048. This one also is 4048, and then this one is 2. So adding this, that's 4050 plus 4048, so that's equal to 8090. So this is for largest, okay? So that's the error for 20. Okay, any questions for 24? Okay, if no more questions, then let's go to number 25. Combinatorics. 5 drugs are chosen at random without replacement from 8 bottles of lemon tea and 10 bottles of red tea. Find the probability that more than 2 bottles of red tea is chosen from those 3. Okay, so first, we need to get the negation. So more than 2. So the only negation is we don't need the negation. So first, we have 3 red tea. So that is our case 1. So if we have 3 red tea, so from the 5 drinks, so 8 bottles of lemon tea, so 3 red tea and then 2 lemon. So just multiply. So for the red tea, so remember we have 10 bottles of red tea, so that's 10 choose 3. And then for the lemon, so we have 8, so 8 choose 2. Okay, just multiply these two. So 10 choose 3, that's 10 factorial times 7 factorial times 3 factorial. Or that's just equal to 10 times 9 times 8 over 3 times 2 times 1. So cancel this, so we get 3, cancel this, so we get 4. 10 times 3 times 4 is 12, 12 times 10 is 120. Next, we solve for 8 choose 2, so that's going to be 8 factorial over 2 factorial and 6 factorial. So that's 8 times 7 over 2 times 1. So cancel this, you have 4 times 7, which is 28. So 120 times 28, so that's going to be equal to 3,360. Next, we have case 2. So we have 4 red and then 1 lemon. So since we have 4 red, so that's going to be 10 choose 4 multiplied by 8 choose 1. So let's start with 10 choose 4. So that's 10 factorial times 6 factorial and 4 factorial. So that's 10 times 9 times 8 times 7 over 4 times 3 times 2 times 1. First, cancel 4, so we get 2 here. You can also cancel that again here. And then cancel 3 from 9, so we have 3. So we have 10 times 3 times 7, so that's 21 times 10, so that's 210. And then for 8 choose 1, that's just simply equal to 8. So we have 210 times 8. That's equal to 1,680. And then finally, case 3. So that's going to be all 5 red tea. So that's just 10 choose 5. So that's 10 factorial over 5 factorial, 5 factorial. That's 10 times 9 times 8 times 7 times 6 over 5 times 4 times 3 times 2 times 1. So 3 and 2 cancels 6. 5 cancels 10, 2. And then 4 cancels 8 to 2. So we have 4 times 7 times 9. That's equal to 252. Now just add the 3 cases. So we have 360 plus 1680 plus 252. So that's 5292. Oh, we're talking about probabilities. Okay. I feel like, okay, I made it solo. Okay, my bad. Okay. Let's try to solve it again. We're talking about probability here. So this one should be easier. Because it is probability, so let's start with 3 red and then 2 lemon. So since this is 5 red and 2 lemon, so let's get the probability first of red. So we have 10 red, so that's 10 over 18, because we have 18 in total, times 9 over 17, times 8 over 16, okay? And then for the lemon, we have 8 over 15 times 7 over 15. And then multiply this with 5 factorial times 3 factorial, 2 factorial. So try to solve this one. That should be equal to actually what we did a while ago was already fine. Let's just continue that one. It's gonna be a long solution. So let's just solve. Case 3 is we already have 5292. And then just divide that with 18, choose 5. Which is 8568. So simplify that one. 5292 over 8568. So that's simplified as 21 over 30. Okay, I think that's it. So let's proceed to 26. What is probability that the sum of the results of rolling two per six-sided dice is a multiple of 4? So we're talking about the sum is a multiple of 4. So the highest possible result is 6 plus 6, so that's equal to 12. So we're looking for results of 4, 8, and 12. So let's start with 4. So 4, we can have 1 plus 3, and we also have 2 plus 2. For 8, we have 2 plus 6, 3 plus 5, and then 4 plus 4. For 12, we can only have 6 plus 6. Okay, now we solve for how many possible arrangement. So if it's different numbers, there's 2 arrangement. If it's same number, then there's only 1 arrangement. So here we have a total of 3 arrangements. Here we have 2, 2, 1, so that's 5. And then here we have 1. And then just add the 4, add the 3. So we have 3 plus 5 plus 1, that is equal to 9. Okay, so we have 9 possible arrangement. And then the total number of possible results is just 6 squared. So that's 9 over 36, which is 1/4. Okay, any questions for 26? If there are no more questions for this one, then let's have the next one. A standard poker deck contains 52 cards, and there are 13 rounds in each of the 4 suits. How many different combinations are there for a straight flush with all of the 5 cards are of the same suit and consecutive rounds? So for this one, we need to get how many possible consecutive rounds. So to do that, all we need to do is 1, 2, 3, 4, 5. Okay, so that's your slowest. And then, so that means your lowest will now be 5. And then your last number is 13, because that we have 13 rounds. So all we need to do is 13 minus 5 plus 1, which is essentially equal to 9. So we have 9 possible consecutive numbers or consecutive rounds. But remember, we have 4 suits, so we need 9 times 4, so that's equal to 36. So as if some of you are playing cards, we know that ace could be the lowest and the highest at the same time. But in this case, the ace is just considered as the lowest, okay? But normally in real cards, when you're playing, it could be the highest and the lowest. But here, again, it's only considered as the lowest. 13 minus 5 plus 1 is 8. Nope, it's 9. 13 minus 5 is 8, and 8 plus 1 is 9. So any questions for number 27? If there are no more questions, then let's have number 28. How many different ways are there to place 5 identical balls and 5 identical cups in a row from left to right? So this one's easy. Actually, you just need 5 plus 5 factorial over the repeating. So that's 5 factorial, 5 factorial. That's 10 factorial over 5 factorial, 5 factorial. So as we know, we can simplify this as 10 times 9 times 8 times 7 times 6 over 5 times 4 times 3 times 2 times 1. So 3 and 2 would cancel 6, 4 would cancel 8 to 2, and then 5 would cancel 10 to 2 again. So 2 times 2 is 4, 4 times 7 is 28, and 28 times 9, that's going to be equal to 250. So the final value here should be 250. Yep. Okay, any questions for number 28? Where did you get 13? Because there were 13 ranks of the cards. Okay, if no more questions for 28, let's have number 29. How many different sets of natural number A, B, C, D, E are there such that AB plus B plus E is equal to 8? Okay. So for this one, all we need to do here is use stars and bars without zero. Without zero because it's natural numbers. That's going to be n minus 1. Choose k minus 1. So your n is 8. So that's 7. And your k is 5 because we have 5 numbers. So that's 4. So that translates to 7 factorial over 3 factorial 4 factorial. So that's 7 times 6 times 5 over 3 times 2 times 1. So cancel this one. So we have 7 times 5, which is 35. Okay, any questions for this one? If no more questions, then let's have number 30. This is the last number. How did I get 7? Wait. I get 7 from 8 minus 1. N minus 1, choose k minus 1. And let's have the next one. How many pairs of natural numbers x, y satisfying to x, y plus 6x minus y is equal to 27 is or are there? So first, we want this to be factorable. So to do that, we have 2x here. Then we also have y here. Okay. So we want to get negative y, so we put here negative 1. We want to get 6x, so we put here positive 3. So this one will be equal to 2xy times 6x plus 6x minus y minus 3. Okay. So to make this one similar to this, we need to subtract negative 3 both sides. So the xy plus 6x minus y minus 3 is equal to 27 minus 3, which is 24. Then we express this in its factored form, which is 2x minus 1 and y plus 3. So we get the factors of 24. So we have 24 times 1. We also have 12 times 2. And then we also have 8 times 3 and 6 times 1. I think that's it. So first, we do trial and error. So we first do 24 times 1. So that's what we can observe. 24 times this one, because 2 times a number minus 1, that would be add, okay? So this one should be add. So we only consider factors with odd numbers. So we remove this one and we remove this one also. So we only have 24 times 1 and 8 times 3 to consider. So start here. So 8 times 3. So that means 2x minus 1 is the add one. So that's equal to 3. And y plus 3 is equal to 8. That's what we can observe here. We have 2x is equal to 4, which means x is 2. And y is equal to 8 minus 3, but that is 5. So this is your first pair. If we try this one, so your add is 1, so that means 2x minus 1 is equal to add 1. That means 2x is equal to 2, x would be equal to 1. And y plus 3 is equal to 24, which means y is equal to 24 minus 3, which is 21. So this is our second pair. That means we have two possible pairs. Okay, that's the last question. So before we end, someone was requesting for number 2. Let's discuss that one last time, and then we can end. So again, guys, a recording of the lecture would be emailed to you. Also, a copy of the solution manual.
Hey, Mr. What's the answer for number 30 again? And what's the solution?
Number 30 is 2 pairs. Oh, wait, the solution here is quite long. Just watch the recording na lang. Just watch the recording. Okay, I'll send the solution file. Wait, I'll send it in the chat box. Just a second.
Can you give the solution for number 30? Or
Wait, I'll send a copy in the chat box. Okay, can you see the copy now? I've sent in the chat box. So just download it, and also a copy of the recorded lecture will be emailed to you, so you can all watch that again if you want to go back to some numbers. Okay, so that's all for today. Goodbye and
Hi, sir.
Yes, sir.
Good. Goodbye, sir.
Yes, sir. Thank you.